In my last video, you learned to craft a single, great message, a perfect prompt, and that is a genuinely powerful skill. But now I want to show you the bigger discipline that prompt is only a small part of, because here's a secret about how real AI products actually work. Open up a serious AI system, a coding assistant, a customer support agent, a chatbot that remembers you from last week, and you will not find a single message. You'll find a whole payload of information assembled fresh every single turn. Your question, yes, but also the conversation so far. Documents pulled from a database, the results of tools it just used, memories from past sessions, all of it packed together and handed to the model at once. And someone or something has to decide exactly what goes into that payload, what to include, what to leave out, what to shorten, what to put first. That decision, made well or made badly, is the difference between an AI that feels brilliant and one that feels lost. That discipline has a name. It's called context engineering, and over the last couple of years, it has quietly become the most important skill in building with AI. As systems grew from single chats into agents juggling tools and documents, the hard part stopped being how you phrase one message and became how you assemble everything the model sees. This video is about that art. Context engineering, the real skill behind every AI system. Let's build the whole picture. Part 1, drawing the line. Prompt engineering and context engineering get used almost interchangeably, and that causes real confusion. So let's make the distinction crisp, because it's the key to everything that follows. Prompt engineering is about how you word a single request, the role you assign, the examples you give, asking it to think step by step. It's the human craft of writing one great message. It's what my last video was entirely about, and it is absolutely worth knowing. Context engineering is bigger. It's about what information the model can see when it answers. Not just your message, but the entire window of text handed to it, assembled by the system across a whole task. If prompt engineering is writing one great sentence, context engineering is deciding everything that goes on the page. So here's the relationship. Your prompt is one item in the context, an important one but just one. Prompt engineering lives inside context engineering, and as AI shifted from answering single questions to running long, multi-step tasks, the center of gravity moved. The prompt matters. But what surrounds it matters more and more. So to understand context engineering, we have to understand the thing it manages, the place where all of that information has to fit, and that place has a hard limit. Part 2, the context window is a budget. Everything the model can see at the moment it answers lives in one place, the context window. In my video on how LLMs work, we called it a whiteboard with edges. Here, I want you to think of it a little differently. Think of it as a budget. Because the window isn't free, empty space. It's finite. It holds only so much text, and every token you spend on one thing is a token you can't spend on another. Fill it with the conversation history, and there's less room for documents. Fill it with tool results, and there's less room for instructions. Everything you put in competes with everything else for the same limited space. To put numbers on it, a context window is measured in tokens, those little word pieces from the LLM video. A model might hold, say, 100,000 of them, a few 100,000 at the high end. That sounds like plenty until you realize a single long document can eat tens of thousands on its own. Add a few of those, a long conversation, and a pile of tool outputs, and you blow the budget far faster than you'd ever guess. The window is big. Your ambitions for it are always bigger. And here is the part that trips everyone up. You might think, fine, just use a bigger window and pour everything in. But remember the lesson from my video on RAG. A full, cluttered window doesn't produce better answers. It produces worse ones. The one fact that matters gets lost in a sea of noise, and the model's attention spreads thin across all of it. More is not better. More is often worse. So the entire game of context engineering comes down to a single sentence. Get the right information into a limited space, not the most information, the right information. That tension between what you'd love to include and what will actually fit and help is the problem this whole discipline exists to solve. So let's make it concrete. Here's our empty context window with its budget. Now, let's see everything that's fighting to get inside it. Part 3, everything competing for the window. When an AI system sits down to answer, a whole crowd of information is lining up, each part demanding a place in that limited window. Let's meet them. First, the system instructions, the standing rules that tell the model who it is and how to behave. The instructions box from my video on agentic systems. Then the conversation history, everything said so far in this session. Then retrieved documents pulled in by RAG. Then the outputs of any tools the model just used. Then long-term memory, facts saved from past sessions. And of course, the user's actual question, plus any examples you want to show. Picture a real example. You ask a support agent, "Where's my order?" To answer that well, it wants the company's return policies, your entire order history, the live tracking data from a shipping tool, your last 3 support chats, and its own standing instructions. Every one of those is reasonable. Together, they are far too much to fit. Something has to referee which ones make the cut. That referee is context engineering. Now watch what happens if you try to include all of it in full. The window overflows. There is simply more information that wants in than can possibly fit, and even the parts that do fit crowd and dilute each other. This is the central problem laid bare: a tiny, fixed budget. A huge competing demand for it. So context engineering is really a set of levers for resolving that fight, 4 of them, and we'll take each in turn. Selection, choosing what gets in; compression, shrinking what does; ordering, placing it where it counts; and memory, deciding what survives. Let's start with the most important one. Part 4, Lever 1, Selection. The first and most powerful move in context engineering is also the simplest to state. You cannot include everything, so choose. Deliberately decide what earns a place in the window and leave the rest out. You've already seen selection in action, though we called it something else. This is exactly what RAG does. Instead of dumping your entire knowledge base into the window, it retrieves just the handful of passages relevant to this question and includes only those. RAG is not really about documents. It's a selection strategy, a way of choosing what deserves the budget. But selection is broader than documents. It applies to everything competing for the window. Only load the specific tools the agent needs for this step, not all 50 it might ever use. Include only the relevant slice of the conversation, not every message since the beginning. Bring in only the memories that matter right now. At every turn, a good system is quietly asking, what does the model actually need to see to do this next step well? Here's selection in miniature. Say your agent has access to 40 different tools, sending email, querying databases, booking travel, and on. But for this one step, just summarizing a document, it needs exactly none of them. A well-engineered system doesn't parade all 40 in front of the model and hope for the best. It surfaces the tools that fit this moment and hides the rest. Fewer, sharper choices, and a clearer head. And here's the mindset shift. We tend to think good context means adding the right things, but just as much, it means leaving the wrong things out. Every irrelevant document, every stale message, every unused tool you keep out of the window is budget freed up for what matters. The skill of leaving things out is half of context engineering. So selection takes the flood and narrows it to a clean, curated few, but sometimes even the things you must include are simply too big. So what then? Then you shrink them. Part 5, Lever 2, Compression. Selection decides what gets in, but sometimes the things that genuinely belong in the window are still too large to fit. A conversation that's gone on for an hour, a tool that returned a huge blob of data, a document you truly need. When you can't cut them out, you shrink them down. The most common form is the rolling summary. As a conversation grows longer and longer, the older parts get quietly distilled into a short summary. The full back and forth of 20 exchanges becomes 3 lines. Customer wants a refund. Order number confirmed. Waiting on a manager's approval. You've seen this idea before as the whiteboard that gets summarized to make room. That's compression. Think of it like taking notes in a long meeting. You don't transcribe every single word that's spoken. You capture the decisions, the action items, the numbers that matter, and you let the rest go. A good AI system does exactly that to its own history. The 3-line summary isn't a lossy accident. It's a deliberate act. Keep the signal, drop the noise. The same move works everywhere. A tool returns 2,000 lines of raw output, but only 3 of them matter, so you keep those 3. a long document gets distilled to the paragraph that's actually relevant. Compression is how a system stays coherent across a long, complex task without ever blowing its budget. It keeps the meaning and throws away the bulk. So now we can choose what gets in and shrink it to fit, but there's a subtler lever still, because it turns out it's not only what's in the window that matters, it's where in the window you put it. Part 6, Lever 3, Ordering. This one surprises almost everyone. You would think that if a piece of information is in the context window at all, the model will use it, but that's not quite true. Where you place it matters a great deal. Researchers found a striking effect, often called lost in the middle. Models pay the most attention to the very beginning of the context and to the very end. And information buried in the middle of a long window can get genuinely overlooked, even when it's sitting right there. The model doesn't weigh every part of the window equally. The edges get read closely, the center can fade. Picture a long document with one crucial line buried in the middle. The deadline is Friday. Ask the model when the deadline is, and it may genuinely miss it, even though the answer is right there on the page. Now move that exact same line to the very top or place it right beside the question at the end. Suddenly it answers instantly. Same fact, same window, just a better seat in the room. So context engineering isn't only about what goes in, it's about where. Put the most important instructions right at the top where they anchor everything. Put the freshest, most relevant information near the end, close to the question, where the model is paying close attention. The exact same facts in a different order can be the difference between an answer that uses them and one that ignores them completely. So we choose what gets in, we shrink it to fit, and we place it where it will actually be seen. There's one lever left, and it reaches beyond a single answer across time. Part 7, Lever 4, Memory. Everything so far has been about assembling the window for one response, but real assistants need to remember across many responses, across a whole conversation, and even across sessions days apart. That's the job of memory, and it's a context engineering problem too. There are really two kinds. Short-term memory is just the current window, the conversation happening right now. Long-term memory is different. It lives outside the window entirely in a store where important facts get written down as they come up. Your name, your preferences. A decision you made last month. The window can't hold all of that forever, so the durable stuff gets saved somewhere else. And here's the elegant part. Long-term memory isn't about keeping everything in view at all times. It's about writing the important things down and then pulling the right ones back into the window exactly when they become relevant again. It's why a well-built assistant can remember months later that you're vegetarian, not because it held that fact in the window the whole time, but because it saved it and retrieved it at the perfect moment. Save and re-inject, that's memory as context engineering. But memory cuts both ways, and this is where it gets tricky. Save the wrong things or never clean them up, and your assistant starts dragging around stale, irrelevant facts. Or worse, confidently acting on something that used to be true and isn't anymore. Good memory isn't just remembering. It's knowing what's worth keeping, what to update, and what to quietly forget. So there they are, the four levers: select, compress, order, and remember. Each one a way of getting the right information into a limited space. Now let me show you where all of this matters most and where it gets genuinely hard. Part 8, Why agents make this essential. For a single question and answer, context engineering is helpful. But for an agent, one of those goal-driven systems from my video on agentic design, it becomes absolutely critical. And to see why, watch what happens to the window as an agent works. An agent runs in a loop. It thinks it uses a tool, it observes the result, and it goes again. And every single step more gets added to the context window. Another thought, another tool call, another chunk of output. Left unmanaged, that window doesn't just fill up, it clogs. After 20 steps, the model is wading through a swamp of its own old thoughts and stale results, trying to find what actually matters right now. And its performance quietly falls apart. This is where the real failure modes live, and they're worth knowing by name. There's context distraction, where the useful signal is buried under so much accumulated clutter that the model loses the thread. There's context poisoning, where a single wrong fact gets stuck in the window and keeps misleading every step that follows. and there's tool confusion, where so many tools are crammed in that the model can't tell which one to reach for. Here's the concrete shape of it. An agent researching a topic runs 30 searches. By the 25th, its window is stuffed with 24 old results it no longer needs, and the 3 that actually matter are drowning somewhere in that pile. A well-managed agent would have summarized and cleared the dead weight along the way, keeping only the live threads. That difference, completely invisible from the outside, is why one agent finishes the job and another just spins in circles. Every one of these is a context engineering failure, and that's actually the empowering part. A long-running agent stays sharp not because its model is smarter, but because something is carefully curating its window at every step, pruning the clutter, summarizing the old, keeping the poison out. Context engineering is the invisible hand that keeps an agent coherent, long after a naive one would have drowned. So we've built the whole discipline: the budget, the competition, the 4 levers, and the reason it all matters most for agents. Let's step back and see the complete picture. So here is context engineering whole: a limited window treated as a budget, a crowd of information competing to fill it, and 4 levers to resolve the fight. Selection, choosing what gets in; compression, shrinking what does; ordering, placing it where it counts; and memory, deciding what survives and when it returns. The art of filling the window with just the right information at every single step. And now watch everything on this channel click into place. The context window itself we opened up in the video on how LLMs work. The prompt is one thing you put in it, the craft from the prompt engineering video. RAG is selection from the video on reading your documents. And memory, tools, and instructions are more of what competes for the space from the video on agentic design. Every single video has been a piece of this one picture. Context engineering is the frame that holds them all. And there's a quiet, beautiful simplicity hiding in all of this. Notice that nothing we covered required a smarter model, not one of the 4 levers: selection, compression, ordering, memory. They are all just careful curation of a limited space. The kind of thing you could reason about with a pen and paper. The intelligence was always there in the model. Context engineering is simply how you let it actually shine. And that's why this matters so much right now. For years, the race in AI was for a bigger model, but increasingly the difference between a system that feels magical and one that feels frustrating isn't the model at all. They often use the very same one. The difference is the context. What the model was shown and what it was spared. The future of building with AI isn't just a bigger brain, it's better context. If this tied the whole picture together for you, give it a like, it truly helps, and subscribe because we are building AI up from the ground, one blueprint at a time. Every video that led here is waiting for you right there. Thank you for building this with me. I'll see you in the next one.